Hi everyone, welcome to Scicloj and good evening or good morning based on the time zone that you're in. And today we'll be discussing about Skija, 2D graphics library targeted on JVM. And with us we have Nikita Prokopov. He's an interesting geek with various dimensions. So he has around 40 plus podcasts on his name and also a lot of open source contribution and a lot of interesting contribution that he has done. And for the people from Clojure background, he's the one who has designed the logo for famous Babashka library. So that's a brief about Nikita. And with respect to this talk, we'll be having this talk for close to 2 hours. So this talk has been organized into multiple topics, starting from the intro to comparison and scope of development that'll be in the future plan for this library. So in between each topics, we'll have time for QAs. So any questions that you have on whatever Nikita is discussing with us, so feel free to post your questions in the chat. So I'll be compiling the questions and we'll be raising it in between each sections. And if possible, feel free to turn on your video so it'll be more interactive. And that's it. Feel free to interact and feel free to raise questions. And we'll also be interested in knowing your current background. So either you are from Java or Clojure. So, and if at all you're not into Clojure too much, and if at all you're not getting what we are discussing, feel free to raise it so that we'll see what we can do about it. So over to you, Nikita.
Thank you, Kannan. Hi, everyone. Welcome to the Skeeja introduction. Let me start just by saying that it's so. This Skeeja is a library. It's a JVM library, so basically it has Java API for graphics, right? 2D graphics, basically that's it. The idea is that, and it's basically just a wrapper around Skia library, which is a completely different thing. Not completely different thing, but let me just make myself a little bigger. So the Skia library, this is the library written by Google, and it's quite popular, and many well-known projects are based on it. So Chrome is based on it, and Flutter is based on it. So basically, they use Skia, not Skija, to draw all the pixels to the screen, right? So all the UI, all the bordered shadows, lines, I don't know, whatever images. Flutter also uses it, and in the bottom row there are like Xamarin, which is Microsoft bot. Valonia, which is UI for .NET, so basically Xamarin and Valonia.NET things, and they have wrappers around Skia for C#. Firefox doesn't use Skia for the main page, but it uses for canvas. So when you instantiate a canvas in web page and drawing it in Firefox, you will be drawing into Skia through Skia, and LibreOffice is this black logo is LibreOffice, and starting from version 7, I think they also switched the rendering to Skia. So it's a quite capable, quite well-tested library for doing 2D graphics, doing UI graphics, right? And the only problem was that it was C++ library, which is okay for, I don't know, for C++ programmers, for Chrome, I guess, and for not for Android even. And I wanted something to draw graphics on JVM. Eventually in Clojure, but like building a wrapper just for Clojure seems short-sighted probably, and for any language that hosted on JVM, right? So that's how Skija was born, and Skija is just a very thin layer that wraps C++, Skia library in Java bindings. That's all it does. Whatever Skia can do, Skija can do as well through JVM. And the name is just like one extra letter, J. So it's like most Java libraries do. That's what it is. Okay. It's also later it became a problem because it's really easy to confuse the two names, and people sometimes even don't understand that I'm talking about two different things when I talk about them. But that's very small problem. Yeah, so let me also explain a little bit about the scope of what graphics library does, right? So this is not a complete UI solution. Like, it's not a UI framework that doesn't have buttons or checkboxes or even windows and window events. All it does is it puts pixels on a screen. So basically stuff like lines, rectangles, gradients, shadows. It can draw them into screen, into bitmap. Yeah, so that's what it does. So let me, okay, I'll try to do this. So I draw a stack here. So there's drivers. Oh, I can move this as well. Okay, so drivers, it's like bottom layer that talks to hardware. Then there is OpenGL, right, which like wraps drivers, and Skia and Skija by extension can work with OpenGL, Metal, Vulkan, and I think it has software render as well, so to render into bitmaps or something like that. It has many renders actually. It can even render to PDF, but what we are interested in is like hardware accelerated graphics. So OpenGL, Metal, or Vulkan. So yeah, I don't have examples for that yet, but it is certainly possible when we're working on examples. Then there is window management, OS integration. It's stuff like create a window, handle user events, stuff like that. And this stuff is not covered by Skija at all, right? So many solutions exist in Java space. So there is LWGL, which I use for most of my examples. There's JOGL, JAWT, not AWT, but JAWT. And they all handle the problem of creating a window, initializing OpenGL context and stuff like that, and handling the events. So then don't have to. And then there is like here is graphics, right? So graphics is when you put lines, rectangles on the screen. And this is what Skia does and what Skija does through the Skia. So it expects that you created a window somehow and expects that you created a texture to render in, and then it can work finally. Right? But it also, yeah.
I'm so sorry to interrupt. I just realized something about the recording. I think if you would share your screen, it will appear better on the YouTube video eventually, because it is recording like as a gallery of all the little windows. So if you can somehow share your screen, if it is not a trouble.
I can. Let me. I probably will have to restart Zoom, but yeah, it asked me to restart Zoom. Let me do it real quick.
Yeah, I'm so sorry for that. We never had this special way of presentation that you're using, and I should have thought about it.
Is there a way to put me in Spotlight or something like that? No?
Oh, yeah, but I'm not sure about the recording setup. I will try. I'm trying to look for a moment at the recording setup, and maybe we can make it work. Yeah, so if you are still with this slide, then you may just keep talking for a few more minutes, and then I will update if I find a way to make it work. Yeah.
I do have share
There are
screen.
some suggestions from the audience saying that can you record in speaker view? I think.
Yeah, so I think now you are on spotlight for the audience, but I'm not sure about the recording. So I will try to set it up.
I think if you put me in speaker view, it should be okay.
Yeah,
for
but
recording
recording is on the cloud, and there is some setup there to record the gallery. So so maybe you can forget about me for a few minutes, and I will come back maybe with an answer. So
okay,
sorry.
yeah. Yeah, if you don't find anything, tell me. I'll restart and share screen. Yeah.
Thanks.
No problem. So I was talking about the graphics. So graphics is like this green layer, and on top of it, usually people build like widget library, UI library controls like buttons, panels, scroll views, lists. I don't know that thing. That is not in Skeeja as well. Not in Skeeja. We have Jetpack Compose for desktop in JetBrains, which is based on Skeeja and which solves this problem. So it's like the next layer. So with it, you can create the whole application. You can create widgets, buttons, and stuff like that. But Skeeja is like handles low-level graphic stuff, just putting pixels on the screen. If you want to compare it with Java Swing or Javafx, they cover all three layers, right? So if you use Swing, for example, you have window management built in, graphics built in, and widgets, and all together in one single package. In case of Skeeja, this is decoupled into different layers, so single responsibility for each library. So you can swap in and swap out different parts as you like. Basically how we like things in Clojure, right? Decoupled, not bundled together. Libraries, not frameworks. So that approach works for Skija as well. Okay.
So yeah, I'm sorry. I will stop you again. So we will have to share the screen just in case, just to be sure. That
I'll reconnect.
Yeah, thank you. Yeah, sorry everybody. I should have thought about it, and in a moment we will be fine.
Yeah, actually, it's good that you noticed it.
Yeah, the thing is that we just cannot know how the recording may turn out, because I know we are just recording the gallery unless the screen is shared. So we will see in a moment.
Okay, I'm back. Let me share screen. Desktop one. Okay, so all my tricks about the camera will now not work. But okay, I can use it like this, I guess. I wish I could hide stuff, but I can't. But anyways, okay, at least you can see me now, right? And okay. Now let's go. So this I was talking about this. So let me say, yeah. So this is tells us what Skija does, what it doesn't. It displays basically graphics, and even though it's not a complete UI solution, it's still useful. I believe it's still useful. Well, first of all, you can use it as a basis for like widget and controls, like we do in Compose, right? But then you can do also visualizations, like, I don't know, scientific visualizations, like graphics, and especially interactive graphics, charts with many data points. For example, if you need high performance graphics for some reason, you can do that. As long as it's 2D, so there is no 3D stuff, it's just flat. And then you can build, I guess, games. I guess 2D games probably should be possible, should be no problem for it as well. And then I have actually, I wanted to show you what type of graphics Skeeja supports, and for that I have a demo application here. So it's a little demo time where I just cycle through many examples and just show the basics. So the most basic stuff is graphics primitives like points, lines, polygons, Bezier curves, arcs, gradients, different types of fills, clips, I don't know, stuff like that, right? It's there. Then there are some effects like lighting, shadows, and distortions, different types, blurs. There is very sophisticated like path effects when you can put different shapes on a path and fill paths with different shapes, stuff like that, which also might be useful for some reason. Very sophisticated path library. Basically everything that you can expect from vector graphics editor like Figma or Sketch, Skeeja probably can do that as well. Then there's text. This is still all different types of effects. There's also text, like I don't know, text layouting, complex text layouts, including emojis, bidirectional text, and stuff like that, multiple fonts, font fallbacks. So it does all that very good, right? So it's very high quality implementation. Because Chrome is based on it and Android is based on it, and they need it to be good. So that's why it's also good in Skia as well. So it's not, it's something, if it works in Chrome, it probably works correctly here as well. This is SVG, different, so it can render SVG, it can render gradients, shadows, as I said. This is interesting. We implemented Java 2D graphics in Skeeja. It's not completely implemented yet, so there are some bugs, but especially in this, it's called, I forget how it's called, but the oldest style for Swing, it can render Swing components, but not going to Java 2D, instead going to Skeeja, but the same components. Yeah, there's text effects, scales and stuff like that. This is also different bitmap effects like shattered glass, black and white, stuff like that. You can do that. Clips, images. This is like Figma UI, but in Skija. You cannot draw here with just static picture, but everything here is drawn with through Skija, including icons. So these all are vector icons. Different types of text rendering. So there's also sophisticated text rendering with many knobs to control. It supports variable fonts, open type features, all the modern stuff that browsers supports as well. Let me go back to where? To here. Yes. So this is what Skija is good for. Okay, boom. Okay, next part. I don't have many slides, so I think it's best if we handle questions at the end. I will go through them quickly, probably quick enough, and then we can answer all the questions and have a discussion. So the next thing I wanted to show you how Skeeja works, and as I said, it is Java API. It is Java API. Like you go to, for example, canvas.java, and here you can, I don't know, draw polygon, right? So you call it draw polygon, pass coordinates, pass paint, which is another object that has color and stuff like that. And And yeah, it will appear on screen. Yeah, so the tricky part in implementing this, so Skeeja is not an automatically generated bindings for Skia. So when I started this project, there existed two after-generated bindings, which were pretty bad. They're really hard to use, they're confusing and stuff like that. So we decided to build a library that is like handcrafted, but it also feels like normal Java API. So things make sense. Sometimes for some things, you need to be using native objects behind the Java object. Sometimes you are good with just Java objects. Sometimes there is like stream in C++, for example, or instead in Skia. Skia implements its own streams for reading files, but in Java we have input streams, so you need to build a bridge so that Java users will use input streams, which they used to, instead of like some weird wrapper around C++ library, which is like implemented in Skia and stuff like that. So where things make sense, we use native Java classes, native Java idioms. We use iterators instead of Skia iterators, for example, stuff like that. And I think it's much more pleasant to use than the existing solutions. It also handles memory management for you. So C++, it means you have to manage your memory. If you allocate C++ object, you have to free it at some point, right? And this is not what Java programmers are used to do. So we do a special wrapper. So all the Skeeja classes are extending managed class, which handles memory management for you. Basically, it is a wrapper around C++ pointer, and when Java object gets garbage collected, the C++ pointer gets freed. So you don't do memory management when using Skeeja because it's Java library. Java does it for you. You don't bother about, don't worry about it. But behind the scenes, everything gets allocated and freed in C++ correctly and reliably. And that's the beauty of it. There is a method called close. So if you want to, for some heavyweight resources, you can free them manually from Java. So if you allocate, I don't know, typeface or texture or something like that, it's probably a good idea to get rid of it as soon as possible instead of waiting for garbage collector. So you can do that too, but it is optional, right? So you can call it, you can not call it, whatever you do, the result will be at some point the native object will be freed and closed correctly. So this was a pretty interesting problem to solve, but it seems to work okay so far. Yeah, and then there are just lots of classes. This on the left, all the classes that Skeeja have to drop in one way or another different C++ class. Yeah, this is about the implementation. Okay, and about closure. So closure is not native to Skeeja, but I had it in mind. So because of JVM library, you can use JVM. You can use it from closure, and probably it would be better if there was a closure wrapper around it, because some things are a little trickier to use. But anyways, it totally works. I have an example that works in closure, I think here. And yeah, so the color creation was tricky because the colors are integers in Java, and it's hard to create 32-bit integer in closure. It always tries to create long instead. So this is long, and we need integer, and they're not easily transformable. So yeah, this function I wrote, and then there's draw. So basically there's paint, set color, translate on canvas. Canvas is Skeeja class, paint is Skeeja class, React is Skeeja class, right? So this, and then there is some LJ VGL or whatever to create a window. There's a render loop, and it's in the center of it. You clear canvas and draw on canvas. So yeah, I can show you that it works. If we go, I hope it works. Maybe I need, yeah, change version here. Let's see. No, it doesn't work. Oh yeah, because I need to change this. Sorry, but the examples are set up to work with local build version, not with Maven version. Yeah, and there is your window. You can even, I think you can change, let me see. I think there is something for, yeah, rect color. So we are in, let me just show you. So we have this, and maybe I have reset. No, oops. But anyway, you can have interactive development how you normally do in Clojure. Reset. Okay, let's see if, yeah, so it changes. Should have it prepared, but yeah, so, and the idea actually, the global plan is eventually having this library for graphics for JVM. I would build some UI library for Clojure, because I think Clojure is best suited for UI development because of REPL and interactivity. And from there, we can like develop desktop applications the way ClojureScript developers develop the browser applications with live reload and instant feedback and stuff like that. That would be awesome, I think. Yeah. What else? Okay, let me switch back to here. Performance is, I have about different stuff about it. The performance is pretty good for some, pretty bad for, not bad. So performance for Skeeja is pretty good and solid for most of the tasks that I can think of, that I tried. It is sometimes slower than JavaFX in some tasks. For example, this is the repo I built for testing performance of JavaFX and Skija and AWT eventually, maybe. Right now, it just does 2. So the results, for example, the filling screen with circles, JavaFX does it faster than Skija. But Skija does it reasonably fast as well. But something like clipping or drawing shadows, JavaFX is very, very slow, while Skija is okay. It's doing pretty good. And I think it's, well, I didn't try to do anything fancy, just the stuff that you would expect from user interface, like clips for button shapes, or I don't know, checkboxes, or gradients for button backgrounds, or shadows. Again, the stuff that you commonly see in user interfaces or text, stuff like that. Yeah, and it's pretty solid. It's not like fastest in the world. Again, sometimes JavaFX is faster, but it's pretty solid, and I think
Yeah,
it will be good
one quick
for
question
UI.
here, Nikita.
Sure.
So, whatever you mentioned, less than one, is it in? So, what's the unit of the time that you have mentioned here?
So this is pretty interesting. So let me show you. This is a benchmark where I draw the circles, but they're not drawn as circles, they're drawn as clipping rectangles. So basically it's a rectangle that has a clipping mask of the shape of the donut, right? So, so for example, if you're drawing something like this, you would probably need to clip on the border so you don't overdraw to the stuff that's out of your button. So anyway, so clipping is sometimes is important in user interface. So this is what Skija does and does it reasonably well. For some reason, JavaFX cannot do clipping at all. So if I try to do it, it will be very, very slow. So it can draw like 4 or 6 or 8 clipping masks with like 10 FPS or something like that. If I do this much, it basically goes to 0. It needs multiple seconds to render this picture for some reason. It also cannot draw a donut with clipping mask. I know why. I didn't like research deeply why it is, but it was pretty bad. The same goes with shadows. Shadows are also pretty low performer in JavaFX.
So the unit that you have mentioned there is frames per second, is it?
Yes, it's frames per second, yes.
Oh, okay, fine, yeah.
Yeah, this is about performance. So I think if it's, my judgment is if it's good for Chrome and is it good for Android, it's probably will be good for your application as well. And finally, comparisons with between Java, Skija, and JavaFX. So it's not that I want to compare these two specifically, but with any existing Java solutions, right? So there's AWT, there's Swing, there's JavaFX, and now there's new graphics library. So what's the point? So there are many problems. First of all, as I mentioned, JavaFX and Swing complete solution for UI. Skija only does part of that, so it's not probably a fair comparison, but we can compare on the graphics side and exclude everything else. And from the graphics side, I have a list somewhere. Yeah, here I think. So what I like about the Skija is it gives you high quality, high fidelity with like super detailed control over details of what you're drawing on the screen. So AWT and JavaFX do a decent job, but they are very basic. So you can do basic things, but if you're dedicated to do very, I don't know, high quality and very specific things, if you like pixel perfect thing, they might not be powerful enough. The API might be not powerful enough or wide enough to do what you want. So Skija just has much broader API surface. It can do much more things. It has much more control over what you're doing. And that was important for me, right? So one of the things, so two things actually that I missed when I evaluated JavaFX as a graphics backend for Compose, Jetpack Compose, and for any potential Clojure UI library if it ever happens, was color management, which is, as far as I know, doesn't exist in JavaFX or nor in AWT. So the color and typography, right? So text rendering. So color management is a thing that becomes more and more important, especially for graphics application. And the problem is, before, I don't know, like 5 years ago, probably, I don't remember exactly, 5-ish years ago, most of the displays that we had were sRGB. And so color management problem didn't exist, at least for showing pictures on the screen. For computer screens, you just render a sRGB picture and you're fine. Now Apple started to selling wide gamut displays. So all the modern MacBooks and the Pro display, HDR display, whatever it's called, they wide gamut. They can show more colors than RGB. And this is a problem because if you ignore that fact, you will probably be rendering slightly wrong colors on these displays. So if you just rendering sRGB, your how do I say it? So color management it's a problem that cannot be ignored. You have to deal with it, otherwise you're just doing like a wrong thing. And there are no control for color management for wide gamut displays or stuff like that, color conversions in JavaFX, unfortunately. And then the typography is, and yeah, about color management. And then there are HDR displays, of course, which also have like the different variety of them, but again, they becoming more and more popular, and you have to work with color differently when rendering pictures for them. So it just, the point is, it becomes a problem that cannot be ignored anymore, unfortunately. And if we're planning for building something for the future, we probably have this somehow foundation for this solved right now. The second problem is typography, right? So the text, we live in like in a world where there exist left to right languages, right to left languages, where emoji exists, and UTF-8 or UTF-16 are not enough for everything. There are multiple fonts and font fallbacks. There's also text rendering, which is pretty hard problem to do correctly. And all that also is very important for UI, right? You cannot build a UI if you cannot render, like, right to left text correctly, or if you cannot render an emoji. And all this is, I would say, underwhelming in JavaFX. So I did some quick tests yesterday. I had, for some reason, even just putting text on the screen renders it much bolder than the rest of macOS. So bottom is Skija. This is text edit, so native macOS text rendering. They're more or less the same. JavaFX, for some reason, does renders much bolder text than it should. Then I learned there are still unsolved problems about this, which is LCD text rendering, which shouldn't be enabled on macOS at all. But JavaFX enables it, and then does the wrong job. So as far as I understand, you shouldn't see this type of colors, this saturated colors in LCD anti-aliased text. And then there's also, for some reason, it's 2 pixels wide. I'm not sure why. It should be 1 pixel. The color binding should be for 1 pixel, not 2. But anyway. Yeah, and these problems, and then I tried to render text with emoji. So this is Skeeja on the bottom, and on the top is JavaFX. To be honest, there are two ways to render text, right? You can create a text node, and if you're using JavaFX as a UI library, you're probably not drawing to the canvas directly. You're using text nodes, and text node knows how to render itself. Maybe it works better. I didn't test it. This is like using graphics context. So it's basically a canvas which I put pixels to. But even if text node work better, it's still not perfect. I think that it uses some APIs that you don't have access to. Right? I prefer to have access to all the APIs that the library itself uses. Yeah, then there's like high DPI support, fractional scaling, like vsync, and this is all stuff that Javafx has problems with. And yeah, and the last problem with it is that Javafx is a single thing. You need to use it all together. You cannot use like window management from JavaFX and throw away the rest. You cannot use graphics from JavaFX and throw away the rest. It's not decoupled. So if, for example, I don't like the UI library of JavaFX, I can't write my own. I have to work with what they offer, and it's not the best. So yeah, so this is why I think the graphics library is needed. This is why I think it's needed on JVM. Well, because I work in Java company, right, and we have most our code expertise in JVM. I work in JetBrains right now, and they sponsor this development and plan to use it for Java as well. And then I think Clojure is perfect for UI building, and it's a shame it still doesn't have any UI framework in Clojure. We do have, but I think we can do better. That's all. We have a JavaFX wrapper, for example, but that brings the whole of JavaFX, which is not optimal. Yeah, but that's for the future, right? So in the future, maybe somehow we'll solve window management, UI library, probably in different libraries. So I don't want to put that all into Skija. I want Skija to stay just graphics, and you have a choice of which window management you choose, which UI library you choose, and stuff like that. Yeah, I think that's it. That's all I have to say. I would be glad to answer any questions if anyone has them. But that's
yeah. For the moment, we haven't received any questions from the audience yet. But as a user of Swing in the past, I have certain questions. So the first thing is like so I remember using HTML rendering from Swing. So do we have support for that in Skeeja?
No. No. I think it's like it's the wrong level to solve this problem. So Skeeja is pretty dumb and low level. Just draws what you tell it. It doesn't come with all the stuff that you might actually need. So in that sense, it's pretty limited, I guess, in its uses. It's like foundation for the other stuff, including HTML rendering.
Okay. Yeah. And next question is like, so as you have mentioned, we have a lot of advantages with Skeeja, and there are certain things which is available in the existing Java ecosystem, which is yet to be implemented in Skeeja. So given this scenario, do we have, is there a possibility of developing, is it possible to combine Skeeja and existing JavaFX or Swing together so that they complement each other in a single application, things like that?
It is possible. It is possible, but you have to work on it. Yeah. So one example I can give you, we have Jetpack Compose for desktop, and it's also JetBrains library, which basically it's Jetpack Compose, which is Android library but ported for desktop to building desktop applications, and it uses Skeeja. And folks that are working on it right now, they're working on integration with Swing, and this is two-way integration. I I know that they can render Skia surface in a Swing application, and now they very recently they also learned to draw Swing components inside Skia surface. So it is. Let me show you actually. I think it's in a public channel, so I can probably show you. Here. Yeah, so this is like Swing window or AWT window. This AWT buttons or panels on the border. Inside this clock wall of clocks is Skeeja rendered graphics, right? And inside it, there are two buttons which are also Swing components. So it's like 3-layered cake: the Swing, then Skeeja, then Swing again. And it seems to work. Yeah, there are. Yeah, it works.
Okay.
It's tricky to set up, but it works. Yeah.
Okay. Yeah, and we have a question from audience now. So, so it's from Daniel. So, he's saying like it would be great to hear more about the solution for handling C++ memory release on garbage collection. It is something that we need in Clojure, currently using a nice library called tech.resource. Curious to hear about any challenges you have run into when taking care of that. So he would like to know more about the garbage collection and
Yeah, absolutely.
any interesting issues that you would like to share.
Yeah, it is. You can always go to GitHub. I don't know. Did I show the GitHub? So the GitHub is this JetBrains/Skeeja, and here, if you find managed class, yeah, and make it bigger. So the idea is very simple. You store a native pointer in a Java class as long. It's actually let me switch here. Yeah. So this is native class. It has a long, which is just a pointer to C++ object, right? And it's stored as Java field. Then in managed, there is some machinery which is based on this cleaner, which is, I think, something like JVM solution for, like they used to have finalizers. Now it's like there's different API called cleaner or something like that. So the idea is you put your object in the cleaning queue, and when garbage collector decides to kill your object, to collect your object, you get a chance to do something at that point in time. So there's cleaner sunk, I pass a pointer, and finalizer. So, and then the cleaner sunk goes into native method and calls the finalizer, which is also pointer, and my pointer. For example, if I show you something simple like paint Java, right? So it's a managed object. So it has like a pointer, I don't know, C++ pointer, and then we go to C++ version of the paint. So this is a constructor that creates new paint on C++ side. It creates new paint C++ object, sets anti-alias, and returns the pointer casted to JLong. Okay. Then there's finalizer that just calls delete, and we take a pointer to the function, and we also pass it back to the Java. So Java now has this pointer to the object and this pointer to this function, actually to this function. And so then when garbage collector hits, it calls this delete paint, passes the pointer to it, and it gets deleted. So it's pretty straightforward. One interesting thing that I learned is actually quite recently, this week, actually, is that Java can be pretty eager to collect your object, even if you're like currently in the native method. So the race, we had a race when you're in a native method working with pointers, and Java decides to delete your object you're working with. And that was maybe expected because Java is multi-threaded. Of course, it has garbage collector thread, and of course, it can hit at any time. But what I didn't expect is that while you're in a Java method here, for example, right? So it's a not static method, it's a paint method. It can collect the paint itself. So while you're in an object method, it can collect this. Its method is not finished yet, but if Java sees that for the rest of it, you don't use this anymore, it can collect it. So this was kind of unexpected. So here you can see I have reachability fence that guards this. So until this native method finishes, please don't collect itself. Otherwise, it will be erased here. But yeah, that's basically the gist of it.
Yeah, and we have a couple of more interesting questions and discussion to make. So another question from Stoyon. I hope I spelled the name right. So the question is like, Nikita, do you have any plans to do live coding session, something like writing a simple game using Skija? So I assume that the intention is to get a hands-on feel for both the audience and you.
I actually wanted to do that. Yeah, I used to do some live coding some time ago, but yeah, when I was like, I have data script streams. I think I have RAM streams. Now, yeah, it would totally make sense. I would probably even do it in Clojure because I don't think live coding in Java is much fun. And I also want to try how it feels to use it from Clojure. Even writing like this small example gave me some insights into what Clojure wrapper should be. So yeah, probably if you follow me on Twitter, you'll probably be you can subscribe to it, or you can write to my YouTube channel. I guess it has a much weirder link. It's something like something like this. No. Okay, I don't know which my YouTube link is, but I have YouTube channel. Whatever. No, Twitter is better. So the nickname is Nikitansky. Yeah. Yeah. Somebody posted it. Yeah. You posted
okay.
it.
Yeah. So I think the answer is sometime soon we might have a session.
Yeah.
Yeah. And next is an interesting question, and we have Vladislav, and who is author of CLJFX. So the statement is like, due to its backend, I happen to know a lot about JavaFX. I wholeheartedly agree that JavaFX, being everything in one package, makes me at mercy of the quality of built-in components. I think it's fair to say that JavaFX is neither very bad nor very good. It's somewhere in between. But for UI development, I usually need something higher level than shapes and text. So I would say it makes more sense to compare JavaFX to Jetpack Compose for the desktop. Can you provide comparison between those two? So is asking if there is any comparison between JavaFX and Jetpack Compose that you have.
Mm-hmm. Yeah, I cannot provide. First of all, you're right, absolutely right. JavaFX is something that should be compared to something like Jetpack Compose. Yes, they are complete UI solutions, both of them, right? Then the components are the components I think are tricky because they're still unclear even for Android, which is like upstream for desktop Compose. It's Android Compose, and even there they don't yet know what components should be. But I think most of them, if they're available in Android, they're probably available in desktop as well, because they should basically share most of the code base. So you probably should go to something like Jetpack Compose documentation, Jetpack Compose for Android, and see there. So I don't think desktop does anything differently. I think what it does differently is stuff around Windows. Like I think they have component like window component or pop-up component, stuff like that, or dialogue, something like that, which doesn't exist on Android, right? So they have to implement those. About those, I don't think you have, there is a good place to read, but everything inside the window is probably just straight from Jetpack Compose. As for other comparisons, so, well, they're using AWT, I think JAWT, which is a way to render OpenGL texture inside AWT window. So they are sitting on AWT event queue, AWT window management, but render their own components inside. They use Skeeja instead of, well, Swing uses Java 2D, right? They use Skeeja instead. That's the big difference. And or Javafx uses its own thing. But other from that, yeah, they're probably pretty similar. Well, they're not similar. So okay, sorry for it's just I have so many things and I struggle to say them in order. The biggest difference, like if we move away from internals, from the outside, for the outsider's view, the biggest difference is that Javafx is old style UI framework, the one which has, I think it's based on two-way bindings, right? So they have properties and they have components that react to a change of property, or if you change something like a component, it gets propagated back to the property, something like that. They have like bindings, observable properties, stuff like that. But other from that, I think it's also imperative. Like if you want to create a window, you just write create a window and window appears. If you want to close it, you write window.close and it disappears. As far as I know, I may be wrong here, but that's my intuition.
You're completely right. Yes.
Yeah. Okay. Cool. Oh, hi, Vladislav.
Hi.
So and Compose is like this new way of building UI, which is now it's called Declarative Ui, which was pioneered by React. And the idea is that you build virtual DOM, and then and the library itself behind the scenes somehow synchronizes your state between what you see on the screen, between persistent components and your virtual DOM. So in Compose, you don't retain references to windows and text boxes and stuff like that. You don't have them. Instead, you just call function after function. Instead, you basically write a render function that renders your whole UI as if it's rendered from the scratch every time. And then you call it over and over. And but the engine underneath compares what it has and what you're trying to do, and only calculates diff and applies this diff to the persistent tree. And this approach that React pioneered, that Flutter took, that Swing UI, it's Swing UI, right? The Swing UI took. So, and now there is Jetpack Compose. So I think that's the main players in this area. I personally find it much better way to develop UI. I loved React when it was out. I even wrote a closure script library for React, and it was a joy to use. The fact that you don't have to manage state transitions and you only render UI from scratch every time, it simplifies a lot of things. And I'm glad that Compose joined this train.
Very cool. Thanks for your answer. But now it makes me think that maybe it makes more sense to compare Jetpack Compose to Javafx, which is a React-like wrapper of Javafx. So they really have the same semantics when it comes to defining components.
Yeah, maybe. You're probably right. I haven't worked with it, so I couldn't say much. But if it does this React style thing, it's probably kind of doing the same thing. Yes.
And the next question is like, so it's from Vladislav. So the question is like, in GitHub of Compose JB, I'm unable to find the built-in components. Is there a reference where I can find the components that is supported in Compose?
Yeah. I think I answered it. I think you should be looking at this Jetpack Compose for Android and look. I think they have some documentation somewhere. It should be, but I also need to mention that this is in alpha, so it's not out even for Android. So stuff changes. It changes pretty significantly every month. So it's pretty hard to keep stay updated about it. Everything changes, but I think the Google, they really committed to it. It seems like, and they will probably have lots of documentation eventually. I hope so. I never work with Google, but that's how I expect.
And the next question from Daniel is, are you aware of any other interesting C++ libraries in the ecosystem around Skia that could be useful to build bridges for something for data visualization, for example? So is there any C++ library which can be used to build a wrapper around? It can be used for things like data visualization or things like that.
I'm not. Okay. So the answer is I am not, but even the Skia repo itself has pretty, well, has some, right? So it has SVG library, which is actually in Skeeja, so you can render SVG in Skeeja. They also have the Scotty, which is, I think, a format for SVG animations or something like that. So for vector animations, I think I think vector editors can export it, something like that. Yeah, I'm not sure what else is there, but something like that. Models. There is, yeah. I don't know. Yeah. I think that's it. That's all I know. But they probably are. The Skia has been around for a pretty long time. I think it 10 years, at least 10 years, but probably more.
Okay. So that's all the questions that we have for the moment. So anyone have any questions? So we have a lot more time left. So probably if you are interested to discuss something or anything that you're unclear of, I think we have time to have a detailed discussion, of course.
Can I ask something, maybe?
Yeah, sure, Daniel.
Thanks.
Go ahead.
So again, thank you for the brilliant talk. Really exciting, I think. There is something that we sometimes like to do after we have talks like this one, and that is to go and learn. And I wanted to ask people in the audience if anybody would be interested in meeting afterwards and trying to play with Skeeja from Clojure or not from Clojure, so that we can learn together and try to use it for our needs. So if anybody is interested, then let us talk after the meeting. You have our email, and it would be great to talk. Thank you.
So the email is the one from which we got the invite, right? That's what you were referring to, right? Okay, yeah. So any other questions from audience? or anything that you'd like to discuss? Okay, yeah, I think we don't have any more questions from the audience. Yeah, yeah. Thanks a lot, Nikita, for such a preparation and such an innovative presentation that you started with and you went on. Yeah, and thanks for the work that you're putting in for Skeeja and other libraries and podcasts that you're trying. And if people here didn't know already, so Nikita is having an interesting blog in which he is posting his thoughts and the podcast that he is doing and the videos that we have. So probably you can follow that as well. And I have also posted Twitter handle of Nikita a couple of comments back in the chat. So yeah, I think we are good. Anything else that we have to discuss?
I just want to say thank you for inviting me, and it was my pleasure to talk to you. I hope I wasn't too boring, and yeah.
So especially for me, since I have experience with Java Swing, it gave a different perspective, and especially to see Clojure in action, I was happy.
Cool. And yeah, if you do experiments or start build something with Skeeja, please let me know. I would be happy to know it, and probably I'll put a link to the Skeeja repo as well. So yeah.
Yeah, sure.
Okay.
Yeah,
Thank you. Thank everyone to visiting. Yeah, it was my pleasure.
Thank you, everyone. Thank you. Bye-bye.
Bye.